Hello. Let's get the meeting started. We're actually live on YouTube. Hello, viewers on the internet. Welcome to our meeting. Oh, we got people talking away in here in the room. Okay, we started the meeting. All right, very good. So, welcome to the August Recreational Astronomy Night meeting of the Toronto Centre RASC. My name is Paul Markov. I'll be introducing the speakers this evening. And those speakers are Andy Beaton, presenting the sky this month, followed by Bryon Czarnik, Funtastic Stories of the Night Sky for Public Outreach. And finally, Ralph Chou will talk to us about his solar eclipse trip to Argentina and also deliver the announcements at the end of the meeting. So without further ado, actually, yes, there is a couple of things we want to do first. Show of hands, do we have anybody here for the first time, member or not? Welcome. Welcome. Hope you enjoy the meeting and hope to see you again. And a quick reminder to please put your cell phones on vibrate or mute so that we don't interrupt the speakers. And I think that's it. If I'm not forgetting anything, I'll call on Andy Beaton to present the sky this month.
Is this working? Yes. Hi, good to see everyone again. I've got the sky this month again, so for the next 28 days until the next meeting, this is what we've got lined up. We've got the big picture, planets, the moon. I've decided planetary nebula would be a fun topic tonight. Comets and meteors. I have to have a variable star, or it just doesn't feel like it's me talking. Double star, I wonder if Blake is watching on the internet. Okay. And upcoming spaceflight highlights. So this is what we've got. We're head out around 10 o'clock tonight. We have a fantastic parade of planets. We've got Ceres, Jupiter, Saturn, Pluto, the Moon, Neptune, and everybody's favorite summer constellations, Scorpius, Sagittarius, and the Milky Way boiling up out of the teapot. We've also got a couple of small comets. I don't think anybody's going to see them, but whenever I start up Starry Night, they show up. By the end of the month, we get up early in the morning, and this is what we've got ahead of us. We have Orion coming back to remind us that winter's already on the way. We have Neptune and Uranus. Eris is out there. I don't think any of us are going to be looking for that one, but Starry Night is giving it to us, so let's enjoy it. We're past the summer solstice, so the nights are getting longer again. 9:40 tonight will be the end of astronomical twilight, and the good observing time starts. It starts again at 4:30. By the end of this period, we'll be finishing twilight at 8:55 and starting at 4:55 in the morning, so that's more time for your long exposures if you're out there doing your photography. Important dates coming up. We've got the new moon coming up on the 30th. Moon is at apogee on the 17th and perigee on the 30th, which means we've kind of got an anti-supermoon. I don't know if there's a term for that or not. An inframoon, I guess. September 10th, Neptune's at opposition, so that's going to be your best chance to see that planet. On September 8th, we have a close moon and Saturn pass. We also have the moon passing close to the, which is it? What's the cluster in Cancer? The beehive. Yes, and I didn't put that down because it happens pretty much every month, but it's out there if you've got a desire to get some cool looking pictures. It's listed in your observer's handbook, so if it isn't here, you'll know you can find it. So the moon, first quarter coming up, new moon's coming on the 30th. The lunar X is coming on September 6th. For those who don't know, the lunar X is a pair of craters that, when they're illuminated from a certain angle, appear like the letter X on the surface of the moon. No, unfortunately that should be AM. However, we know that you can see the moon during the day, and with a sufficiently good telescope, you'll be able to see the lunar X even during daylight hours. The full moon is tomorrow night, so that's why we're having this meeting tonight, I guess. There's going to be not much good observing going on. And we also have an occultation of a 5.3 magnitude star, ZC 1129, by the moon. It's not really an interesting thing, but I mention it because if you dig into your observer's handbook, there's an entire section on things being occulted by the moon. This may not be the best one we're going to get all year, but I wanted to draw your attention to it so you can dig into your handbook and find more and better examples of these. Planets we got coming up, Mercury, Venus, and Mars, the rocky planets. Mercury, we'll be able to see it in the morning, probably till the end of the month, then it disappears into the sunlight. Venus is a write-off this month, so is Mars. So save your observing time for October or November. These are the good planets to see, Saturn and Jupiter. I don't know if anybody was out on the weekend when we finally got some clear weather. We're trying to see Perseids, but if you were trying to impress anybody with the night sky, those two planets were the thing to do it with. Early in the night, Jupiter can't be missed. It's super bright. There's been talk about the red spot unraveling. I've got to admit, the last few times I've seen Jupiter, I haven't even seen the red spot. As far as I know, it's still a pale salmon spot and very difficult to spot unless you're looking with a good telescope and a decent amount of experience, even if it is on the right side. Saturn is close behind. The rings are good and wide open. It's not as obvious in the sky as Jupiter is. It's not as insanely bright. Unfortunately, both of them are at low declinations, so there's going to be a lot of atmosphere getting in the way between you and your observing. We've also discovered recently that the rings on Saturn are a temporary feature. They're estimated to have a lifespan of a mere 100 million years and they'll be gone. So get out there and see them while you can. Later in the night and into the morning, we get Uranus and Neptune showing up. You can see Uranus with the naked eye if it's sufficiently dark. Neptune, not so much. You can probably see it with binoculars if you know where you're looking and have a decent map. Neither of them are really big enough to see any detail or anything interesting on them. But if you're looking for something interesting, the moons of either of them make good challenge objects. Triton on orbiting Neptune is probably the easiest. I think it's something like 14th magnitude. So a moderate-sized telescope should pick that up. I haven't had any luck finding any moons of Uranus, but I haven't put a sufficiently large telescope to work there. As usual, if you're looking for dim objects in the night sky, having a camera or a CCD of some type will show up a lot of stuff that you're never going to see with the eye. Pluto, Ceres, and Haumea are all going to be visible in the evening nowadays. Pluto's in Sagittarius, which makes it tough. There's an awful lot of dim stars there. I don't think you can really claim to see it unless you are carefully observing that location and recording all the 13th and 14th magnitude stars around there. I think it's going to require photography to really nail that one down. Ceres is leading Jupiter in Ophiuchus. It's not quite naked eye brightness, but it should be visible with a pair of binoculars. If you're very lucky and have a good telescope and nothing in the way of turbulence in the sky, you may even be able to see a disk. I know I've seen disks of Jupiter's moons at about the same size, but in that case, it depends on it being close to Jupiter, so you can actually get it a bit of perspective as it crosses the limb of Jupiter. Ceres, I guess even if you did see a disk, it would be hard to tell, but it'd be worth trying. Haumea is in Boötes. 17th magnitude, I think, is well beyond anybody's telescope here for visual observing, but it would be an interesting project to try with a sufficiently large telescope and a camera. 17th magnitude should be in reach of the telescope up at the CAO. If you took a picture, say now, and went back in the spring and took another picture, that would probably be long enough to show some motion. So I always like to throw in a bit of deep sky stuff. It's a very good time of the year to go looking for planetary nebulas. All the greatest hits are up in the sky right now. The Ring Nebula, the various dumbbell nebulas. The blinking planetary is a fun one. I like that one because when you look at it, it disappears. It's one that really requires averted vision. And you can confuse and astound guests looking through your telescope with it. M27 is a particular favorite of mine. It's large and bright. It's actually very good for viewing in the city because it's very well suited to filtering out the wavelengths you don't want. Any nebula filter or an O3 filter, which is what I use, makes it glaringly obvious even in the city sky glow. For a challenge, once you've seen M27, knocked it off your Messier list, finding the central star is always fun. Finding the central star of any planetary nebula is an interesting project. The blinking planetary is kind of a gimme, but finding the central star for the Ring Nebula is it's a challenging object, and I actually haven't managed it yet, but I'm working on it. And there we go, there's M27. That's what it looks like in a photo anyway. If you're looking at it with an eyeball, you generally just see the red part, if I recall correctly, giving that dumbbell look. In black and white. Well, unless you have really big eyes. So comets and meteors coming up. There's still a few Perseid stragglers out there. They'll probably be out there for the rest of the week. We've got the southern Taurids coming up. It's in many ways a pretty lame shower. I think they predict between 5 and 10 an hour, which isn't very many, but they do have a high proportion of fireballs. So it's probably worth looking there if you're going to be out looking at the sky anyway. I'm not sure I'd make a special trip to see them, but fireballs are always an attraction. Meteor dribbles, the Oreoids and the September Epsilon Perseids, these guys are 2 or 3 meteors an hour. Once again, I wouldn't bother looking for them, but if you see a meteor during that time period, trace it back, see if it's one of those, just out of a sense of curiosity. So we do have some comets. Pan-STARRS, 9th magnitude in Taurus, and it's getting brighter. Africano, 10.5 in Camelopardalis, also getting brighter. The other ones, not quite so impressive. 11.5 in Ophiuchus, 11.5 in Pisces, and 12th in Aries. And I believe those ones are fading away. But if you're a comet completist and want to see all the ones possible, now is the time to catch them. Can't let you go without having you learn about a variable star. S. Aquili is a semi-regular type. Its spectral class is M, so it's a nice red one, and that's fun because it's hard to estimate brightness when you're looking at things that are very red. So this is one you'll want to practice with a bit. It's very educational. Ninth to, that should be 12.8th magnitude, not 128th. That's the magnitude of the planets around it. 145 day period, more or less. The reason I bring this up, I want to talk about the AAVSO Legacy Long Period Variable Program. As you probably know, since the past 20 years have come along, we've got survey telescopes taking automatic images of the sky every night. And the question in variable star circles is, what's the point of observing these things when they'll get scooped up by these automated surveys anyway? The reason is, well, there are two reasons. One, some of them are variable faster than the Sky Survey's daily image. Cataclysmic variables, things like that, can explode over a couple hours. The other reason is that we have data for many of these stars going back to 1911. And you can't really use that data unless you've got a consistent benchmark going all the way through to the present time. So what the AAVSO has asked is that people keep observing a list of legacy stars with the visual observations, so they have a benchmark to compare the survey telescopes to the 100 years of already collected data. So if you're interested in doing variable star observing, I recommend this one. It's a nice, easy one to find. It's right overhead. It's got a nearby companion, which is very good for comparisons. So if you're looking for a variable star to entertain you, this is a good one. We have to have a double star as well. Alpha Hercules is one I was looking at last weekend. And it was a good one because my first attempt to split it failed. I had an 8-inch telescope looking at with a 26 millimeter eyepiece. I couldn't split it. Seeing was not perfect, but cranking up the magnification helped. And when I did crank up the magnification, what I noticed was the primary was very, very reddish, so red that it made the secondary look green. It was very, very attractive looking. It took a certain amount of effort to find. Once I have found it, it makes a nice object to show off to people too. Like Albireo, it's a good star for convincing people that stars have different colors. It's also an interesting optical illusion because the secondary isn't really green. So spaceflight coming up, not a lot really exciting stuff. There's a new Soyuz rocket variant is being tested next week. Cosmoquest.org is still looking for volunteers to help map the asteroid Bennu as part of their OSIRIS-REx project. If anybody's interested in getting their fingers on some real science and helping out, I strongly recommend digging into this. The Light Sail 2 is up in space now. We're a bit too far north, but if anybody is traveling down below 42 degrees north, or if anybody on the internet out there is watching from further south, keep an eye for the Light Sail satellite. It's around 6 magnitude. It's visible on a good night or with a pair of binoculars. And from late August until the next meeting, the space station will be passing by late in the morning. And as always, heavensabove.com is the place to go for all your times and locations. And always, because I know what astronomy is like, is in Toronto, something to do if it's cloudy, I've been listening to a bunch of astronomy podcasts in my spare time. These are some of my favorites. There's about 2,000 podcasts out there that you can dig into. But if you're looking for something new to listen to, if you don't have any of these on your player, give them a listen. And that's what we've got. And are there any questions? Yeah.
Sorry, that double star, the separation of 4.6, shouldn't you be able to see that easily in 8-inch? Was it the skies maybe, or the colors, the red and the green?
I couldn't.
So faint.
And I'm going to either blame the separation or I'm going to blame the fact that the seeing was not outstanding that night. Either way, if the seeing isn't outstanding, as it often isn't, then it is a bit of a challenge. I couldn't tell you how it works on a perfectly still night.
What was the magnitude difference between two stars?
2 stars, I think, were something around 3 and 5.
Okay, that's not bad.
So when you've got a telescope on it, you could definitely see the second star there. Tom.
With respect to the brightest comet you mentioned, there's a little bit of discrepancy going on the internet about how bright T2 pan-STARRS is at the moment. Aerith is reporting both magnitude 8.7 and magnitude 13.
Okay.
So I'm not really sure what's going on, but I was hoping I'd take a chance to see it when I was up at the CAO last week, but unfortunately I didn't get a chance to. So there's a little bit of weirdness going on with the reporting brightness of this comet.
We're probably dealing with a discrepancy between predicted and reported brightness. If I'm going to have to guess, I'm going to say the reported brightness is lower than the predicted brightness because that's how comets work. Anyone else? Yeah.
Is Africano brightening?
According to the internet, yes. Once again, predicted and observed may be two different things. Okay. All right. Thank you very much,
Andy.
Okay. All right. Welcome, everyone. Tonight, I'm going to talk about the awesome and fantastic stuff in the universe and space. Stuff that there's lots to talk about. How big are things? How far? How hot? How cold? How fast? How downright weird stuff is and unbelievable compared to what people normally see on Earth. So, out of many types of things in the night sky, I've collected a few. Okay. Maybe if I don't move my head.
You're good there.
Okay. So I've collected some short snippets here, some comparisons, analogies that would sort of make it more real and memorable for visitors to our star parties. For instance, a few years back at the DDO, one of the people visiting, the guy said to me, a star party, where do you serve the drinks and the food? I thought, well, maybe he's a little bored or maybe it's just tongue in cheek. So making it exciting for some people is very easy. You know, you get the people who are looking through a telescope for the very first time and they're enthralled by it, or the person who's checking the end of your scope after they're looking at Saturn inside and they're wondering, you know, do you have a toy model there that they're looking at? Hasn't happened to me, but I think it happened to someone in our group. But it's not always that easy. The skies might not cooperate with clouds all over the place or in the places where you've picked a target. And things may look like a fuzzy blob. You give some decent, interesting facts, you think, and some people, they're not impressed. Or maybe you just want to do something and enhance their experience and make it more memorable. So the average person isn't too enthralled by a fuzzy patch unless you tell them something, tell them a little story about it. So you pick a bunch of targets across the sky, some cool facts about them, and there's one fact to remember. If you can't answer a question, the answer is always hydrogen and lots of time. And I like to have some props around cell phones, apps on them, or a tablet, or maybe some graphics and charts, and I'll talk about them, show you some. And a little story or something about it, a little more convincing than what this person is trying to do here. You picked the wrong target, I think. So let's start out. Number one. Some of you have seen this before, but if you take all the planets and line them up between Earth and the Moon, this is all to scale, and the distance between Earth and Moon is to scale, they all fit. So this is like about half of 1% of the solar system mass, with the sun being everything else. And it can be pretty impressive. And of course, you can flip Saturn sideways, and the rings stretch almost from Earth to Moon. So you've got a number of talking points here that you can get into with people, maybe while they're waiting in line to look through the scope. But it's possible that you could get carried away, as I sometimes do, and it's just too much information, at least for some people. So how about this? Here we've got the Moon replaced by one of the gas giants, and this is what it would look like. Wouldn't that be an awesome sight? So while they're waiting to look through the eyepiece at Saturn or Jupiter, you could show this and start talking about the planets, about how Saturn is the least dense planet, and if you threw it in a giant swimming pool, it would float. That always gets people interested. And then you can start talking about other things about Saturn. Or you talk about Jupiter, how giant it is, with, 11 Earths lined up in a row is the width of Jupiter. And yet that giant planet spins around in just 10 hours. And it has dozens and dozens, I think 79 moons now, but your poor visitors are only going to see 4 of them in your telescope. So you can start a whole conversation, people can ask questions. And speaking of the Moon, we've got our own handout here of the Moon. Have people and little kids in the lineup try to pick out the man on the Moon and the other things on the Moon. And some of the targets you can look at, I often have binoculars that I can hand out, and they can look at the Moon while they're waiting to look at, the craters, the craggy surface. It's always handy if you have an app or some sort of map of what they're going to look at on the moon so that they can identify things and orient it. And I like to use an app called Moon Globe. It's free for iOS. There's Moon Atlas, there's others for iOS. For Android, you've got Lunar Map Lite that's free, Loonscope, Moon Atlas, and there's others. But something like that can show them the different craters, information about them, where the spacecraft have landed on the moon, and set up a bit of a discussion and some interest. And of course, the kids like to move the moon around and expand it and contract it on your tablet, so that's always fun. So switching to the night, from the night sky to the daytime, there's the sun. So Sean here handles solar observing, and well, it can be a bit of a nightmare these days because you bring up the sun. Most of us have white light scopes, so there's a beautiful image of the sun these days. You have a 1 in 3 chance of seeing sunspots. So I sometimes wonder whether these days of a low solar cycle, whether hydrogen alpha scopes and Herschel wedges are really hot sellers these days. They may be. So what I like to do is always have solar eclipse glasses. Now, I'd love to have this for people to try out, but unfortunately I don't know any welders. But I try to pick solar glasses that have that carbon color to it because it gives an orangey color and people love that, and you get a lot of oohs and ahs like the pictures from last weekend's solar observing here. And I also have a few props that I bring along. This is not a great picture, but a little ball that represents the sun. And then I picked some beads and a bolt that represent planet Earth and Jupiter. And then I have a contest with the kids and adults to guess which is Earth and to guess which one's Earth. And so far this year, I think it's about 50-50, the guesses. So Earth is bigger than it looks in some people's minds. And you can have a whole dialogue about how big's the sun and information about that started from something like that. Now, here are a few sun facts. I mean, there's a gazillion you can talk about. You can talk about the size stuff. So holding over 1 million Earths, that's pretty amazing. Holding most of the mass of the solar system, or that it takes tens of thousands or hundreds of thousands of years for the light bouncing around inside to get to the surface, and then only a short time to get to our eyes. Or you can talk about, the life cycle of the sun. You can talk about how hot it is, a whole variety of things. The only thing is, be careful about too much information. You could get carried away here. So another thing that I have a little Ego box with a DVD in it in a slit. It's taped up sort of like this. And for young kids especially who really can't see that well in a telescope, or little older kids who don't want to look, or young kids who don't want to look through it, everyone wants to look for the rainbow in a box. So making this homemade spectroscope, it's very easy, it's a lot of fun, and it gets a decent reaction. Now, flipping to the night side, if you're interested, you can buy a star analyzer 100 or 200 that you can attach to your eyepiece and see the spectra of brighter stars like Vega. And if you spend a little more, you can get software that you can collect data and analyze it. I think Eric talked about that a couple of years back. So the sun, our star, how far apart are things? So the things talk about are how big are things, and try to relate that to something people can understand or fathom, or how far apart are things. So if the sun was the size of a soccer ball, and its nearest star, Proxima Centauri, was the same size as, it's actually probably an eighth of the size, but was a soccer ball too, then they'd be at either side of Canada. That would be the distance between those stars. So that's pretty amazing, the amount of space between stars. And you can use this analogy if you want to talk about, say, the Andromeda galaxy and our galaxy merging in several billion years. The stars won't very likely crash into each other because they're so far apart. You make it more amazing, but a little more complicated if you blow it up to the size of the actual star. But that gets maybe a little too much. This is one of my favorite to talk about if you've got a crowd that, you know, is engaged and is willing to hang on for a bit. This comes from NASA and JPL, the bottom link there, nightsky.jpl.nasa.gov. They have tons and tons of different outreach material that you can search through under their outreach section, and this is one of the really nice ones. It comes with a whole explanation, some handouts, PowerPoint presentations. They do a very, very good job. So the idea here is there's 200 billion plus stars in the Milky Way, and that's a big number, and no one can really fathom how big that is. So this makes it real. So what you do, there's maybe a child in the group that's about 4 foot tall. You say, well, if you stand at the corner of the field, we'll build a fence as tall as you all the way around, and then we'll send all these dump trucks out to all the PetSmart stores across Ontario and buy all this bird seed. And we load it into the center of the field so it piles up as tall as you are. And that would be about 200 billion stars if each of those bird seeds was a star. 200 billion, that's 200 billion. Actually, the bird seed would represent a red supergiant star in the model that we continue with. And we make a model of the Milky Way. So we take all that bird seed and we spread it from coast to coast across the United States. And we spread it the same distance from Mexico into Canada. Over the middle of the United States, around Illinois and Kansas, we spread it a little higher. So over the middle, we're going to go up 80 miles, which I think is 130 kilometers high, to show the bulge in the Milky Way. And everywhere else, we're going up about 40 kilometers or 25 miles high for the thin disk. And then our solar system would be a loonie just south of Toronto there in Cincinnati, the middle of Cincinnati. And our sun would be a speck of sand sitting in the middle of that loonie. And that would be the Milky Way. So we figured out what 200 billion looks like and what the Milky Way would look like if we modeled it. So I love this example, and sometimes I have people who have the patience to go through it and really like it too. Now, another thing we could model, I talked about Andromeda and our Milky Way colliding. So here's the Milky Way, and it shows that curve that scientists recently discovered. Our sun's there about halfway out from the center. So it's very, very thin, only about 1,000 light years thick and 100,000 light years across. So that's a ratio of what? 100 to 1. So what's like that a CD or DVD is? So one CD or DVD could represent that 100,000 light year Milky Way galaxy. So you hand that to one of the kids in the group, and you hold on to the other one that's the Andromeda galaxy. And you go about 8 feet apart. So with our scale of 100,000 light years, the 8 feet would represent the 2.5 million light years that our two galaxies are currently apart. And then you say, okay, well, walk towards me real slow, like take 4 billion years to walk to me. And that's the actual motion. Mind you, because of their combined velocity, they're approaching each other at something like 300 kilometers a second. Is that right? 300 kilometers a second, yeah. It's quite amazing, and yet we've made this model, we shrunk it down so much it doesn't seem that big at all. But there you are. And another one I was looking for, I eventually found it. I had it before but lost it. The Astronomical League in the US came up with this poster that you can go to the link and print it out. And it's kind of neat because it shows our galaxy up here in the top, and this box here is expanded down below here. The cross here marks our sun, and the circle here around the sun, and you see it there at the top, it's quite small. That circle contains all the stars that we can see naked eye. So there's like, 4,000 light years out. That's how far this circle goes. And virtually all the stars we can see in the night sky, naked eye, are in that small patch of sky. In fact, 1,000 light years out, 90% of the stars we can see are out that far. So it can be a pretty amazing talking point, and to illustrate things about our Milky Way. Now, everyone has probably seen the Hertzsprung-Russell diagram, and we have all these wonderful stars shown here. The big stars here live fast and furious, and they die out in only millions of years or hundreds of millions of years. Whereas the smaller stars down here, they live a very long time, billions of years in comparison. And that's all pretty amazing, but maybe it's getting just a little TMI for some people, and maybe try something like this. Talk about star nurseries, teenagers, and seniors as far as stars go. So star nurseries, well-known ones like Orion Nebula here, in the summer the Trifid, M17 and Omega, M20. Well-known clouds of gas and dust forming stars actively now. On the right we have the Pleiades or Subaru, with its nebulosity from these recently formed stars. And recent isn't like, 10 years ago for humans. For stars, it's millions of years. And down at the bottom, we have the seniors, the old folk of the Milky Way. the globular clusters that are almost as old as the universe, 12 billion years. And there's lots of them in the summer sky to pick from, to show people, and then talk about the different types of stars. Maybe it's a little more interesting than the Hertzsprung-Russell star chart. This is another graphic or chart you can print off from nightsky.jpl.nasa. It gives one of the basic cycles for forming, for the life cycle of smaller stars like our sun, and for giant massive stars that result in neutron stars or black holes from a supernova. So if you're showing planetary nebula, like Andy was talking about, this can pull out and you can use that to talk to it a bit more. If you're hunting down the supernova remnant, you could talk about this. If you're showing the black hole, or you're talking about the black hole near the middle wings of Cygnus, the swan, high above us when you're at the DDO. Cygnus X1 was discovered at the DDO. You could talk about the life cycle here of a black hole. So this is handy in a number of ways, and you can get it white on black, black on black. Has a whole bunch of material explaining it, PowerPoints on black holes and so on. This is one of my favorites, the blinking eye test. I remember once we had a bunch of astrophysicist students coming to the DDO, and I showed them this and did the eye test with them, and they'd never heard of this before, so it's kind of neat. So it looks, like a faint gray patch with maybe a star in the middle. Because of our rods, 100 million plus around our eye, we can only see the dim stuff, and we have very few cones in comparison that only sees the bright stuff. So staring directly at it, maybe about 150 power works well. You can see the bright central star, but then you look with the side of your eye, and it's a challenge for some people, so I have a contest sometimes, and quite often the kids win. The star disappears, so it's called the blinking nebula. So it's a fun thing to do, and the most fun of all the planetaries, I think, although the ring nebula is pretty impressive due to its size. Let's go to supernova. So the right-hand side of that life cycle of stars, the same website has monthly star charts you can download that show what are the stars like Deneb here with the cross there that are likely to go supernova. And it gives a little information about each of them. So each month you can print one of these off. My favorite is actually not on this chart. It's Mu Cephei in Cepheus, which is so easy to find using the pointer stars to Polaris and keep going through, or between this star and Polaris, it's right in the middle. Easy to, whoa, wrong discussion. It points you to Cepheus, but then Mu Cephei is down here. So it's very a nice star to look at, very red. If it were at the center of the solar system, it's so large it would go between Jupiter and Saturn, extend that far out. It's fusing iron now, so any time it could go to supernova. Any time in stellar terms is thousands, millions of years. But since it's 2,800 light years away, we don't know if it's done it already. And then another slide is what are some of the elements you can get on the right hand. I think this is dying on me, my pointer. On the right hand side, some of the elements you can get only from supernova, or mainly from supernova. And down below, things that those elements provide us with our lives, our daily lives. Calcium in our bones, or silicon for our electronics. Where would we be without supernova? So the classic line, we're all made of stardust. And lots of people show the double-double. It looks pretty neat with the two stars, two pairs of double stars close together. And you can find lots of interesting facts about epsilon 1 and 2. They're all about the same brightness. They're very close together. Their orbits are in terms of hundreds of years around each other. But wouldn't it be more fun, since it's the double-double, we call it the Canadian Connection, Tim Hortons double-double. So it's more of a fun story down below, if you call it Tim Hortons double. And an interesting thing I found on Sky Safari in the notes there was that if you're in a spaceship at one of the pairs, looking at the other pair, they would be about twice the width of the full moon and as bright as the quarter moon. And then you can mention about the pairs circling around each other in hundreds of years and the two pairs going around in hundreds of thousands of years. Just a little something to add to looking to the double-double. Now, astrodoodles. I don't know what it is about astronomers, but over the years we've come up with constellations and we have the line diagrams, but I mean, Pegasus, yeah, it sort of looks like a horse if you have the lines drawn out, but honestly, these 4 stars in Aries, how does that look like a ram? So I call astronomers Imagineers. But we do have things that do look like what they are. The Big Dipper is the obvious one at the top that we'll all talk to, but there's lots of others. The coat hanger is a favorite. I usually have a pair of binoculars, or I like to have a pair of binoculars that I put on a tripod and point at it, or show people how to find it, and then they try to find it with the binoculars and they get pretty excited when they do see it. There's a hockey stick, a Lucky 7, Napoleon's hat here next to Arcturus. Might need a bigger aperture scope so that, and put Arcturus out to the side so that you could see it better. There's a golf putter and a backwards 5, and there's others. And these asterisms, they look like what we say they are. So often the question of, do you believe in life and other planets? Sure I do. I bring up the ET cluster or the OWL cluster in near Cassiopeia. And I could show that, but here's something again from NASA that's useful and interesting. They have monthly charts, and on the charts they show stars, brighter stars, that have planets. And one I like was the one I mistakenly went to before that's easy to find with the pointer stars pointing through Polaris and right to Gamma Cephei, one of the brightest stars with planets, binary I believe. Initially it was 3 Canadians in BC that, using radial techniques I think, thought that it had a planet, but it wasn't really thoroughly proven until 2002. But this could be something you talk to people. Maybe not all the stars you want to show are maybe it's not a great night to look at faint fuzzies, maybe you're looking at stars, here's something you might consider doing. And what if it's hazy or cloudy, speaking of that? So I have a few bright stars that I like for the summer. Arcturus, it's a fast-moving star, and it's kind of interesting that it opened the Chicago World's Fair with its light using the light that left the star the previous Chicago World's Fair. How that came to be and someone thought of that, I don't know, but that's kind of interesting. My favorite is Vega. Vega is spinning almost at breakout speed, and it bulges about a quarter in the middle. It's spinning so fast. Our sun goes around in over 20 days, 26 days or so, but it goes around in 12 hours. So it's almost at its breakup speed. That I find a little interesting. Or if you're in the later fall, winter, Betelgeuse, one of the brightest stars. It's pretty far away. Red supergiant could go supernova, and it may have already. It's the first disk to be imaged, so you could have a picture on your tablet showing the image of Betelgeuse. And finally, I come to my number 10 plus, or 17 to you. What would it be like to be inside a star cluster? What would that look like? Can you imagine that? I came across this story by Isaac Asimov, Nightfall, and there's a planet, Calgash, that in the story has 6 stars that it's orbiting around. Now, that's not a stable system, but this is what Asimov approved. But astronomers haven't come up with a stable system. But the idea was that every 2,049 years, the stars would line up so that 5 of them were all lined up, and presumably on one side of the planet. And the sole moon that was in the sky that you couldn't see because it was light all the time would eclipse the other sun, and you'd have about 15 minutes of darkness. And generations of people living just with sunlight all the time were terrified and went crazy and so on. Interesting story. So what would it be like? And by the way, this Calgash lived in a star cluster with 30,000 stars in the night sky, which only happened 15 minutes every 2,000 years. 30,000. We have 9,000 from 6.5 magnitude down. Say we see half of them in one hemisphere and half of them at the nighttime, so we're talking 2,500 stars versus 30,000. Big difference. So what might it look like? A few years back in Astronomy magazine, astronomer did an analysis of 47 Tuc, a beautiful globular in the southern hemisphere. About 500,000 stars, sort of like the Hercules cluster, M13. So it probably holds if you're showing M13. So if you were in a spaceship, or if Earth were transported to the center of M13, the night sky would be so bright, 20 times brighter than the full moon. There'd be over 130,000 stars in the night sky versus the 6,000 you would see. The brightest stars, there'd be 10,000 brighter than first magnitude, and we only have 29. It's just amazing. So this is intended to depict what the night sky might look like to naked eye inside a star cluster. So that's an interesting story, and it might get people talking, get people engaged. I hope you liked my 10 examples. There's lots of great material in the top reference there, and I've mentioned some of them. And there are all these other references you might consider going to. And just want to thank you all. There's many more interesting facts and stories. I'm always looking for some myself, and I hope you do too. So thank you again. And does anyone want to raise some questions or Ed? I had to pick the one furthest away. I like to give Paul a workout.
Certainly. I'm wondering, having done outreach, and sometimes your mind kind of freezes up and questions come.
Yeah.
How do you queue up all these things? How do you have them at hand? Do you have like computer? How do you know all this right off the top when someone asks you?
I have a computer here. How do I know? I've gone through some of these over time, and before the star party or whatever, I have some idea of things I might look at, so I just refresh my memory on those, or I dig up some more dirt on some things if I don't have anything, like the Vega thing or Arcturus. And I make a few notes on a little piece of paper. I still use paper a lot. And I wing it. I mean, if you don't know the answer, you always say you don't know it, or I'll look it up, or, why don't you look over there and I'll look it up and come on back in a few minutes. I can always say hydrogen plus time. So, over here, Andy.
I've used the Tim Hortons double-double story before. You can elaborate on that by popping over to M57 to show them the donut that comes with it.
Oh, I like that. Excellent. Excellent. Anyone else? Okay. Well, thanks very much.
Well, good evening, everybody. The eclipse last month in Argentina was my 21st total solar eclipse. And for this one, it presented a limited number of choices as to where to go to see it. I've had the experience of observing from the sea. And while there are some charms to that, if you're going to take photographs of an eclipse, a seaborne observation deck is not exactly the best way to do it. You know, you have to point at the sun and then wait till the ship stops its roll. Click, 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 and smear it all over. So instead, well, the South American eclipse had a number of choices available. A lot of people went to La Serena in Chile, which is not too bad. It's a seaside town north of Santiago, and there is a good road that you can take along the coast to get there. Great, except that everybody wanted to go to Chile because it was earlier in the day, and therefore the sun would be higher in the sky. The other chance was to pick somewhere along the path in Argentina. And of course, the problem was that the further east you went, the later in the day it became. And notice that Buenos Aires was just outside the path of totality here and would see the eclipse near sunset. Up here in the western part of Argentina, there was a lot of opportunity for places to go, but not very many places to stay. And in fact, the two biggest towns in Argentina where you could get accommodations were Mendoza, which is the bigger city, and San Juan, which is right on the eclipse path itself, right on the edge. So anyway, I found a tour that was going to be based out of San Juan, and there were plans to go up further into the eclipse path. And here we've got the blow up of that part of the map. So here's San Juan, the capital of San Juan province. There is this nice road here, which you can take up and go quite a bit further out along the way. And there's this winding road that gets you up to the eclipse path. There are a couple of towns up here where the local municipalities had set up observing sites. So our group ended up meeting up in Buenos Aires, flying into San Juan, and then we had a chartered bus which took us around to various places for the day before the eclipse, and then on the morning in question, we went up this way. So anyway, we ended up at a place called Bella Vista, Argentina, and here's the times. So first contact would be at about 4:15 in the afternoon. Second contact about 20 to 6, and it was all over 2.5 minutes later. And the one disadvantage was being further along the eclipse path was that fourth contact would have occurred at 6:45, except by that time the sun would have set. So this was going to be an eclipse where we could get at least totality and a bit of the outgoing partial, but not much else. Anyway, here's my itinerary. I left on Friday, 28th of June on Air Canada Flight 92. Turned out Jay Anderson and his wife were on that flight, as were Chris and Liz Malicki of the Mississauga Center, and Dave Whaley and Alan Whitman from the Sunshine Coast Center. And I met Jay in the airport lounge before we boarded the flight. The other four I saw as we were getting off the flight in San Juan, or rather in Santiago. And all of them were going to La Serena in one way or another. And there were at least another half dozen other eclipse chasers on board that flight as well. Nice thing about going to Santiago is it's straight south from Toronto, 10-hour flight. For me, I had to go through another checkpoint, and then 3 hours later, I was in Buenos Aires. So there was minimal jet lag. And I managed to sleep for about half the flight, so I wasn't in too bad shape when I arrived in Buenos Aires anyway. My group was 40 people, 2 people from Vienna, Austria, and the rest were Americans on the tour, and only a few of them had any kind of eclipse experience. So it turned out that I ended up being sort of the eclipse resource for the group. And we flew into San Juan on the 30th. They took us off to the Ixigualasto National Park, which is a UNESCO designated heritage site where there's a lot of Triassic fossils that have been collected over the years. And it was a very, very interesting place to go. Lots of really interesting geological stuff to look at. And our first visit to not only a vineyard, but also an olive oil pressing facility. Between olives and grapes, they have an awful lot going on in Argentina. Apparently there are something like 1,500 wineries in Argentina. I think we probably saw about half of them. But in any case, so on the 2nd of July, we gathered at 8:30 in the morning at a parking lot in North San Juan, and we had an armed escort from the local police. They were really concerned that with all the foreigners coming in, all in one place, that we would be ripe targets for kidnapping and other things. So they had a police guard that drove up with us, an armed guard in front, and one in the back to shepherd all the buses up. Not that they stick around and came back with us afterward, but you know, that was the way it was. So they escorted us at least the 3.5 hours drive up to Bella Vista and then left us there. And then we saw the eclipse and then came back on our own in the evening. The rest of it, there was a bit of a tour of the town of San Juan and then riding down to Mendoza, visiting the vineyards on the way. So if we weren't corked before, we were certainly afterward. Next day, there was a bit of a relaxation at the thermal spa around Mendoza. And then on the 5th of July, we were to fly back to Buenos Aires for our onward travel. The only problem was on the morning of the 5th of July, all the Argentinian pilots went on strike and they canceled all the flights. Talk about that afterwards. But in any case, that was the trip. Here I am with my setup. So I've got the Ioptron Cube Pro with the telescope mounted on it, my camera on the back with a remote control on it to trigger the shutter. Notice the ankle weights to keep the camera from flipping the tube up to the zenith. And notice that in this shot, which is taken in mid-afternoon, I'm in shirt sleeves. So this is the middle of the Argentinian winter, and I'm in shirt sleeves at the time, which isn't bad. Here's our site, prepared by the local authorities. So these tents right here are the dining tents. We had waiters serving us a barbecue lunch in there. This pavilion back here was for souvenir sales. There was a big kitchen back here where they were doing all the barbecuing, and then there was another bit of shopping over here. And here's my group all arrayed, ready to go, facing towards where the eclipse would occur. We kidnapped a tablecloth from the shelter here to try and look at shadow bands. It turned out the tents themselves were a perfect screen for looking at shadow bands. The only trouble is, notice that they're behind us. Throughout the afternoon, they had local entertainment, several groups who came up onto the sound stage and presented a few numbers. So it was really quite well set up. And no, there were no terrorists or kidnappers anywhere. Here's the site looking towards where the sun would be at eclipse. That's the Andes Mountains there, and the sun would would be in this position for totality, and then come down like this afterward. So it was a perfect sight. And notice no clouds in the sky at all. The only problem was that this is an old, this is a farmer's field, lots of dust. So the camera bodies still have to go in for massive cleaning, as everything was coated in dust. At any rate, here we are. So Eclipse started on time, and here's my shots of the diamond ring going in. With that little telescope with the very, very fast optics, even at ISO 100, look at the shutter speeds to get the diamond rings, a 2,000th of a second. Didn't have to worry too much about vibration, but I did have the camera, or rather the tripod, on vibration isolation pads, and I had balanced so that we'd not have too much trouble with that. In this, you notice that we've got a hint of some prominences. There turned out to be a very nice big loop prominence here, but it's very faint. And there was another prominence over here as well. So the sun was showing some interesting things, but in the partial phases, I usually try to take photographs where you can see how the eclipse is proceeding, with the moon coming up to and then covering up sunspots. This time there weren't any to look at, so it was a bit different. And there's the last little bit of Bailey's bead there before totality begins. And just starting to open up the shutter, so 500th a second and 125th. Here's the longest one that was really of much use, a 15th of a second. You can start seeing the extension of the equatorial streamers here to either side. And there's some very nice fine polar streamers here that don't show up on this projector, but certainly look very good on the computer monitor. I did take shots up to about 5 seconds duration, but they're all burned out. I'll be able to get some data from them when I start stacking everything together, but that's for some other time. Final shot of the total eclipse at 125th of a second, and then here is the terminal diamond ring. I only got one shot of this with a 500th second exposure. So it worked out fairly well. You can notice the prominences here that are showing up just at the end of the eclipse, and there's that loop prominence down there showing up as well. So really nice eclipse. By the time this shot occurred, which was around 5:45, I was in a winter parka. The temperature just plummeted. It was unbelievable how cold it got. So when they called us for dinner, I ran. Anyway, here's my last shot of the eclipse, a 1,000th of a second as the sun sinks behind that mountain ridge. And, so overall it was pretty successful as far as taking a look at the eclipse. I think the only thing about Argentina, that was the 4th Wildcat pilot strike this year. And so while it might be attractive to look at Patagonia in December of next year for the total eclipse, I'm thinking maybe Chile may be a better bet, because I do not want to be faced with what happened 2 days after this shot, because we found out that the pilots had gone on strike. We still had to turn up at the airport so that the airline could honor its commitment to get us to Buenos Aires. And they did get us to Buenos Aires. At about 48 hours after this shot was taken, they put us on a luxury bus for a 16-hour ride to Buenos Aires overnight. I got into Buenos Aires at 10 in the morning at the airport. Our regular tour bus was waiting for us there. They got us to the hotel. I had about an hour and a half to get everything repacked, have a quick shower, and then head for the airport to fly home. And so it was a rather rough trip back. I had 2 days, I got home at 5 o'clock on Sunday morning, and then on Tuesday at 10 in the morning, I was off to Victoria for a meeting. So, and I didn't get back from that until the following Saturday. So it has been a rather hectic time. But anyway, the eclipse is history. I'm back seeing eclipses in clear skies again. So I think 2020 in December is certainly a good possibility of doing something, and a few folks have talked to me at the awards picnic about the possibility of organizing something for April 2024, as well as maybe even the annular eclipse in October of 2023. So I'm seriously thinking about a couple of expeditions for those, because I don't know about you, but I sort of feel a little bit uncomfortable about motoring down to Niagara in early April with a single road, the QE, or, the QEW, at that time of the year. So I think I'm going to vote for Texas, where at least it'll be warm and maybe we'll have clearer skies. So anyway, there we are. That's the 2019 solar eclipse. Boy, they go fast. Well, hopefully we'll get some more chances to stand under the sun's umbra, or rather the moon's umbra, at some point in the next few years. Okay, so thanks. Okay. Any questions? Bryon.
Well, last image there over the mountains, there looked like there was something weird going on between the moon and the sun. That dark central shadow and two shadows on the right.
Well, the mountain ridge was there, and the edge of the moon was coming up together, and it's sort of like that black drop effect that we were seeing at the transits. Same kind of illusory appearance. I think it's just simply, you have the two contrast edges that are coming close together, and your eyes start playing tricks with you. Yeah. Got an online question there, Adrian?
Yes. Peter just asked, how many eclipses have you seen?
I've seen 26 solar eclipses, of which 21 are total. And I've had 2 successful annulars.
This one is from me. Weren't you a little bit under the weather while you were there?
Was I a little under the weather yet?
Yeah.
Yeah, I was. My grandchildren gifted me with a nice cold just before I left, and it blossomed while I was in Argentina. So yeah, it made traveling a little bit difficult. I will say, it was very, very dry in Argentina, which helped a little bit with the nose. But, on the night as we were going back after the eclipse, we actually stopped at the side of the road because people asked me to give them a tour of the southern sky. And it was clear. We stepped outside, and there was a wind about maybe 60 kilometers an hour where we were, and there was a wind chill of about -10. So the tutorial was very quick.
Ralph, during totality, did you have a chance to enjoy the eclipse visually, or you were too busy photographing?
Oh, what I did was I just did the one sequence of shots, which took me about 15 seconds, and then I just sat back and watched. And that is really important to do. You lose an awful lot if all you're doing is looking into the finder. Yeah, it was really, really nice. And the problem was that there was a lot of dust in the air. So while it was perfectly clear, there were supposed to be a few bright stars in the field as well as Venus, and I didn't see anything. But it was nice.
Was the cold later in the day due to the altitude or some sort of reverse Chinook coming down the mountains?
I think it's probably a combination of things, because the winds certainly were very, very variable throughout the day. While we were setting up, it was warm, there was almost no wind at all. And then as sunset approached, wind started to come up. And part of that may have been due to the cooling effect of the umbral shadow approaching. But afterwards, it got really cold. Once the sun was gone, it was freezing. I've forgotten how high we were. We weren't really, really high. Maybe about 2,000 meters or something like that. So it wasn't too bad. Certainly you could run around if you had to and not be short of breath. But yeah, it was really cold.
Blake asked, did you see any of the shadow bands?
I didn't actually see shadow bands because I was too busy working the camera. But some of the folks that I was with, I had told them to watch for them. They said yes, they did see them. So at least a few of the group did see them.
Any more questions? No? Very good.
Okay.
Thank you so much, Ralph, for...
Okay. Before I get into the announcements, I'm just going to take an advantage here to present an award certificate to one of our members. When we had the awards picnic last month, Arnold Brody wasn't able to be there. And as a member of the DDO committee last year, Arnold was a participant in the activity that got us started at the DDO again. And so the DDO committee collectively were presented with the 2018 Andrew Elvins Award, and so I'm going to take advantage to ask Arnold to come up and receive his award certificate. So thank you very much for all you did. Thank you, Arnold. Okay, so what's coming up over the next little while? Well, our next meeting is going to be another recreational astronomy night on September the 11th. And we don't have somebody for the Sky This Month yet, do we?
A little hard time this month. Next month to find someone.
Okay.
Hoping that,
So we need a volunteer.
yes, I'm
or-
working on
Yeah.
a good guy.
Okay. Well, so it's not somebody who's going to be voluntold.
Maybe a little.
Okay. So anyway, the famous TBA will be presenting the Sky This Month in September. Then Dennis Gray is going to be presenting a review of the Pegasus Pocket Power Box. And Steve McKinney is going to be presenting on the Sue Laura Observatory, your astrophotography rig at the Carr Astronomical Observatory. And of course, the SLO is our latest enhancement to the facilities at the Carr Observatory. And if you have a digital SLR, you can put that onto the telescope in that observatory, and you have all of the stuff there to get started in doing astroimaging. So we'll look forward to hearing about what is in there at the next meeting. We'll be resuming our lecture meeting series as well in September, and on the 25th we have Major Ted King coming to talk to us about SARSAT, which is the worldwide search and rescue system. And actually, Major King is a relative of Betty Reed. And so he's going to come and tell us about Canada's role in setting up SARSAT and the international system that is based on it. And I had an opportunity to take a look at a publication of a series of reports on SARSAT recently, and Major King played a really important role in getting that whole system up and running. So we will be hearing about SARSAT from somebody who was really right into it from the start. So it should be an interesting meeting. Solar observing, again, our next session will be on Saturday, 7th of September. And as usual, Sean is going to be giving the go or no-go decision on that, either on the Friday evening or first thing on the following Saturday morning to let you know when to come out.
Actually, Ralph?
Yep.
The cloud date is going to be not the following Saturday, but the one after the 21st.
So in case of bad weather on the 7th, we'll be using the 21st as our backup date. Okay, thanks, Sean. Other observing, we have the Dark Skies Star Party the week of the 26th to the 29th of August, and then the following week, first clear night, 2nd to 5th September, is our City Star Party at Bayview Village Park. And again, in the normal way, we'll have the announcements of go or no go on each night until we get it through the system on all of our media. We also have a lot going on elsewhere in the GTA. Our next event at the David Dunlap Observatory is a family night program on this coming Saturday from 8:30 to 11. And if you could help out with that, we'd certainly appreciate it. And again, there's many roles that can be played at these events to make them run smoothly. And so you can contact DDO at RASC-TO.ca if you're able to help out. There's also a very special outreach event that we've been asked to participate in. And this one's a little bit different. On the 23rd of August, the Deputy Mayor of Richmond Hill is holding a star party and movie night. They're expecting about 1,500 people at the site. I have no idea where they're going to park. But they would like us to provide telescopes on the lawn for astronomy, as well as tours of the dome. And in return, you get free food. Apparently, they are going to be putting on quite a show there that evening. And then they're running the movies. Again, I think the movies are going to be on an outdoor projection screen of some sort. So anyway, it'll be interesting to find out. Chris, if you're there, you'll have to tell us all about it afterwards. Yeah.
Shuttling people in on buses.
Shuttle buses in and out. Ooh, boy. Should be interesting. Okay, well, into September, we have a busy month coming up. It kicks off with the Millennium Square Stargazing Night on Friday, the 6th of September, from 6 till 11 p.m. And there is a special additional feature to that program that night, because one of our sponsors for that program is going to be officially handing over a donated telescope to the Pickering Library as a kickoff event for that evening. So again, it should be quite interesting to see how that works. The following weekend, we have an astronomy night at the DDO. Again, we'll need some help there, and our own Paul Delaney is going to be the speaker. Don't know what he's going to be talking about, but Paul has just come back from a 6-month sabbatical. He's in the middle of installing the new 1-meter telescope at York University, so he's got lots of things he could possibly talk about. Could be interested to see what he has to say that evening. The same evening, again, very, very busy, because downtown we will, at the same time that program is going on, we will be taking care of a few thousand people along with the Dunlap Institute's students and staff on the back campus of the University of Toronto on Harvard Street. From 7:30 to 10:30, we will be setting up to point telescopes at the sky and talk astronomy during the evening. So there will be information booths. The Dunlap Institute is providing door prizes to the attendees, and should be an interesting time. Last year we had about 3,000 people there for that event, and apparently they've put out the word early so we could have even more that night. If you are going to help out with that, please let us know ahead of time, because they will block off parking spots in the parking area beside Hart House for you to park your vehicle and bring your equipment in for that evening. Same weekend, something else going on. The work party for the fall at the CAO. And so Saturday and Sunday, there's a lot of work to be done to get the property ready for the winter. And yeah, September, we're already thinking of that. But again, there's a lot of things that have to be done in advance, and so we're taking advantage of the good weather in mid-September to do that. Again, you know, bring your work clothes. The crew will get you working, and they'll train you if need be, and you get your food and accommodation covered by the center. So again, it can be quite a nice thing to do, and you know, I've been a participant in many of these over the last 20 years, and you know, it's a good time, and you do learn things. I know how to tape drywall now. Towards the end of the month, we're also helping out with the 50th anniversary of the Science Center. It's hard to believe this place has been around for 50 years. And on the week of the 24th of September, we've got 3 days that we've been asked to help with providing solar observing. And instead of being out on the telescape, we're going to be running the entire day from the solar patio. And that's the location that we used to use for astronomy programs here, and it's where we ran the CBC's national coverage of the 1994 annular eclipse. So that area is being set up for us to run for these 3 occasions. And finally, just a reminder that the CAO is available for you to book facilities, including getting time on the SLO telescope. And you can do that all online. All you need is your RASC ID and password to get into the members area of the Toronto Centre website. Also, is there anybody who's here for the first time tonight at all? Ah, okay, welcome. One of the benefits of membership that you may not be aware of is that we do have a loan program. So if you don't already have a telescope and are thinking of getting a telescope, then this is an opportunity for you to try different types of telescopes and other rigs to figure out what works for you. And there's no charge for that. And you just need to contact the managers of our loan program, and they'll set something up for you. So again, it's a free benefit of membership in the Toronto Centre. Okay, and finally, the open invitation for the meeting after the meeting over at the Granite Brew Pub on Eglinton and Mount Pleasant. And again, we'll be there in a little while to have something to drink and maybe something to eat. So anyway, that's it for now until the beginning of September. So enjoy the rest of the summer, and we'll see you on the 7th.